Hey everyone, my name is Jeremy McPeak for NetTuts, and today I'm going to talk about JavaScript performance, specifically functions, and how we define them within our code determines, well, not really determines, but impacts the performance of our application. And you might think to yourself, well, is performance really important? And to that I say absolutely yes. Performance is directly linked with the user experience. If our application performs horribly, then the user is going to have a horrible experience and not use our software. I mean, after all, we write software for people to use. If we're not going to do it right and write something that's efficient and performant, people aren't going to use it, and then, we wasted our time. And we also have a wide array of users. We are no longer targeting people using desktop and laptop computers, but people that have smartphones, tablets, and netbooks. These are limited computing devices, and we need to make sure that we don't use a whole lot of those systems' resources because, once again, we could degrade the user's experience with our application. And then we also have some operating system vendors that are targeting web developers. Microsoft is a perfect example with Windows 8. You can write Windows applications using HTML, CSS, and JavaScript. There's also going to be some capabilities for mobile operating systems that are targeting web developers to write applications for those particular platforms. So it's no longer going to be running. Well, we will still write software that's running within the browser, but also running on the operating system either through a higher privileged version of the browser or just the browser itself. So we need to be sure that we write the most efficient and performant code as possible. So today we're going to look at an anti-pattern, or at least I consider it to be an anti-pattern, and that is nesting functions inside of other functions. Now, I don't mean that every nested function is bad, because there are obviously times when we want to do that, but I think it gets overused to the point that it's being used for no particular purpose other than being its quote-unquote modern JavaScript programming. So we're going to look at some examples and fix them so that they are more performant, because what essentially happens is we waste CPU cycles and we can also use more memory. So here I have a function called foo, and foo is really a glorified addition function. There is obviously better ways to add two values together, but I needed an example to demonstrate this pattern, so this is what I came up with. So we have foo. It accepts two parameters, a and b, and then inside of foo is a function called bar. Bar takes a and b, adds them together, and then returns it. So whenever we execute bar inside of foo, in the last line, bar gets executed, gives us our new value, and then returns it. So if we were going to call this function, it would look something like this. And the result would be 3. Now, I think people forget, or they either don't know, that functions in JavaScript are values. They are objects. Whenever you define a function within your code, it essentially creates a function object whenever the JavaScript engine loads that code. So whenever the JavaScript engine loads the code that we have here, it's going to load the foo function. It's going to create a foo function object because foo is in the global scope, at least as it's written right here. So it will create that foo function object, and then it will move on, and then it will load this next line, which is executing foo. Now, we have a function bar inside of foo, but bar doesn't get created until foo is executed. So whenever we execute foo, it creates the bar function object. It then executes bar, and then since there's no closure around bar or anything like that, when foo exits, bar gets destroyed because it's no longer needed, it's no longer held in memory. So with every time we call foo, we create the bar function, execute it, and then destroy it. So we can call foo 100 times, and 100 times we are creating bar, executing, and deleting it. That's a little inefficient if you ask me. And you might think, well, what's the big deal? If functions are just another type, what's the difference between a function and other types of values like the a and b parameters or some other variables? Well, there's two things. First of all, it's a function. We have to create it and then we have to execute it. And execution involves its own overhead. So if we are creating the function and then executing it, we're doing two things when really all we should be doing is executing it. Ideally, we would create the bar function outside of foo so that it's automatically loaded when the JavaScript engine loads our code, so that all foo does is execute bar. So we would free up some CPU cycles from having to create the bar function and then delete it after we're done with it. And the second thing is functions are primarily static. Whenever we create a function, we rarely ever change it. There are some times we do, but 98-99% of the time we leave a function alone. They're written to perform a specific task, and if we change that, then that task changes. And that's completely different than a parameter or a variable. Even the word variable means that it's going to change. So functions are supposed to stay the same. We're not supposed to really recreate them over and over again. We're supposed to create them once and then execute them as many times as we need to. So how do we do that? Well, the concept is easy. We want to define the bar function in a context where, one, it's only created once, and two, we can call it wherever we want to. Well, since we're dealing with the global scope right now, that would be the best place to do it. After all, that's where foo is defined. So the first thing we will do is cut and paste. So we will move bar out, and it is now defined within the global scope. When the browser is loading our JavaScript, it will load the foo function object as well as the bar function object. So we can call both of those functions anywhere we want, and they are only created once. But we're not done here because bar used the a and b parameters that were passed to foo. Well, that's easy enough to fix. We will just let bar accept those same parameters, and then we will pass those values whenever we execute bar. So now we have a more efficient version of the code that we had before. In fact, this is 15% to 90% faster, and that depends upon the browser. Chrome was at the 15%, Firefox was at the 90%, and IE and Opera were in the middle, about 40, 60, 70%, somewhere around in there. So it is faster to define your functions outside of each other so that the JavaScript engine doesn't have to recreate those functions over and over again. And of course, this is a very simple example. Just imagine the more complex code would actually see better performance gains than just 15% in Chrome. Of course, the refactoring would be more complex, but it would be worth it in the end. If you want to run some of the tests that I created using this example, you can look at the link inside of the article and run that yourself at jsperf.org, is it? I want to say so. So that's great. This is more performant, but I don't like it because it's in the global scope. So let's, nest it inside of another function. Let's add some white space here. And then execute it. I love auto formatting. So now we have two functions nested inside of this anonymous function. And you might at first glance say, well, this is bad. We just made our code worse. Well, yes, we did nest functions, and yes, we did add, some overhead, but this is acceptable here because we are executing an anonymous function. And whenever that anonymous function is done executing, it's gone. We can no longer execute it anymore. It executes once. So whenever it executes, it loads the foo function, it loads the bar function, and then anywhere within this scope, we can use those two functions, and we're not polluting the global scope, and of course, we are keeping our code safe from any naming collisions as well. So this is an acceptable pattern of nesting functions. The outer function here is an anonymous function, and sometimes anonymous functions can be more dangerous than named functions. The reason being because named functions like foo and bar here, because they have a name, it's implied they're going to be executed multiple times. Otherwise, why would we create their function in the first place? But with anonymous functions, we use them in situations where they get explicitly executed multiple times. An example would be wiring up an event handler. So let's set up an event handler for the document. Add event listener, and let's do something easy like click, and then we are going to pass an anonymous function. And this is a very common pattern. There's nothing really wrong here. I mean, this is just common. We are setting up an event handler and we're passing a function to handle that event. You can create a named function and use that instead, but for the most part, this is very common code. But the problem here is every time the user clicks on the document, the function for this event handler is going to execute. And so this can execute multiple times, and especially if the event is a mouse movement-based event, it's going to fire multiple times within a second. So if we have an inner function defined within our event handler, that's obviously bad, because if it's firing multiple times within a second, then it's going to have to recreate any inner function over and over again, which is going to waste CPU cycles, and it's going to degrade our performance. But other than event handlers, we also use anonymous functions quite frequently in other situations. I'm going to paste in the code for a very simple jQuery plugin. It's called My Plugin, and it uses more complex code than what's really needed. All it does is set elements color to whatever color is specified that we pass to it, but it does so in a way so that we can demonstrate this particular pattern. So let's go over the code first. Of course, it's called My Plugin. It accepts an options object, but then we use the each method, and this is an iterator method. So with every element that's selected, whatever function we pass to each is going to be executed. So if we use code like something like this, and My Plugin color, let's do red. Okay, so if we have 10 anchor elements within our document, then the function that we pass to this each method is going to execute 10 times. So this is a rather explicit use of anonymous functions being called multiple times. And inside of this function, the first thing we do is we get this, and then we create a jQuery object with this, so that anytime we want to use this jQuery API, we can do that. Then we have an inner function called change color, and this is going to actually do the color changing for our elements here. So we call the CSS method, we pass in an object specifying color, and then whatever color was sent with the options object, and then we execute color. Now this is following the same pattern as the foo and the bar example, where we have change color inside of a function. Now we want to move change color outside of this anonymous function, but even if we do that, it's still defined within My Plugin. So if we call My Plugin multiple times, change color would still be created multiple times. So we want to move this outside of this anonymous function and the My Plugin function. We want it to be within the context of this plugin, because we obviously want to use it within the context that, or at least within the scope that My Plugin has access to, And let's copy this, and we'll paste it outside of my plugin. It's still inside of this anonymous function, so it is protecting our code from outside interference, and it's also protecting the global scope from being polluted. And naturally, this is using information that we had inside of the anonymous function being used for each. So we do need to do some refactoring. We have the jQuery object, $this, and then we also have the options object, and then the color value. Well, this might be easier if we just had a color value. So I'm going to call that value. And then we also need these parameters. So I'm just going to use $this for the jQuery object, and then value for the color value. And then we need to pass that information, so we'll do $this again, and then we need options.color. So now we have optimized our code in the same way, except we have done it in a more acceptable way than we did it with foo and bar. We did it so that it's still defined within this anonymous self-executing function, so that change color is created once, and then we call change color whenever we need to inside of the plugin. As far as performance is concerned, we do see a gain in performance by optimizing our code in this way. All browsers showed an increase in performance, but that increase was considerably smaller than what we saw with the foo and bar function example. With this example, we see a less than 1% to a 15% increase. So while it is faster, it's just not as much faster as it was. But we see this because of two different reasons. One, we are now working with the DOM, and anytime you work with the DOM, you are incurring some type of performance cost. So that's one reason. The other reason is we are using the jQuery API. Naturally, it's not going to be as fast as native JavaScript, and the each method iterator is notoriously slow. It is much, much, much slower than native JavaScript loops. So we are seeing that as well. And of course, this is a simple example. If we had more functions that were nested inside of the plugin initializer or within the each iterator, we would see a greater performance gain by refactoring that code out. I have seen some scripts that list 5, 10, 15 functions inside of the iterator or the initializer. And in that case, there would be a considerable performance gain by optimizing the code. So once again, the complexity of the code is going to play a large factor in the amount of performance that you see. The next variation of this anti-pattern involves nesting functions inside of constructor functions. And this is where I think this anti-pattern was born to begin with, because some developers had some perceived need to try to emulate private variables in JavaScript. And I say try to because you can't really emulate private variables, at least as they are implemented in languages like C#, C++, and Java. You can kind of get there, but JavaScript just can't do it. It just can't currently. This particular example does not address anything about privacy. We're going to get to privacy in a little bit. We're just going to start with a simple constructor function. And this code creates a person data type or constructor function, whatever type of terminology that you want to use. But it's a person data type. The constructor accepts a first name and last name. Those are assigned to properties of the same name, and then there is a method called getFullName, and that concatenates the first name and last name properties and then returns that value. Unfortunately, this anti-pattern is not only being used in normal everyday code written by Joe Everybody, but it's also being used in teaching material, in books, and online tutorials and presentations, where there's no warning to the effect that this can have to the efficiency and performance of your application. And the inefficiency comes from the fact that we are defining the getFullName method inside of the constructor as opposed to on the prototype. Because JavaScript is a prototypal language, it's based on prototypes. Take prototypes away and you have a useless language. You won't be able to do much with it. So if you do not embrace JavaScript's prototypal nature, then you are writing inefficient code. Now there might be one or two instances where that's not the case, but 99% of the time, if you don't use the prototype, your code is inefficient. That's just how it is. So what makes this inefficient? Well, let's look at an example. We're going to create a person object. I'm going to call it Jeremy, and I'm going to use my information. So Jeremy for the first name, McPeak for the last name. And we have created a person object. Well, whenever the constructor function gets called, of course, the first name and last name properties are created, but then a new function object is created and assigned to getFullName. Now, we already know about the CPU issue where we are basically wasting CPU time, but now we are wasting memory because this function object is unique for this Jeremy person object. So that is being stored in memory because getFullName is a public member of the person data type, so that is being stored in memory. So let's create another object. We're going to call it Jeffrey. We'll pass in Jeffrey's information. And now we have created a new person object. And this person object has a completely different getFullName method. And in order to prove that, if you were going to execute this code, all you would have to do is Jeremy.getFullName does not equal Jeffrey.getFullName. And that would be true. So we end up with completely different methods being stored in getFullName. And that means we are using more memory per person object. So if we were to create 100 person objects, each of those 100 person objects would have a unique getFullName method, and each of those would be stored in memory. So if getFullName consumes 4 kilobytes of memory, that would be 400 kilobytes of memory being used simply for the getFullName method. Now you might say, I will never create 100 person objects, and that's probably true. But also keep in mind, once again, the simplicity of this example. How many times do we create data types with just one simple method? Usually we have at least 2 or 3 methods, and then even those can be greater in complexity. So as complexity grows, the amount of memory and CPU time is going to grow as well. So we can make this code more efficient by defining the getFullName method on the prototype as opposed to inside of the constructor function. So we are going to move it outside and then define it on the prototype. And if you're not familiar with the prototype object, remember that every function is an object, and as such it has properties and methods. One of those properties is called prototype, and to get to it we use the function name dot prototype and then dot whatever it is that we want to define. In our case, the getFullName method, and we already have that, so we are done with refactoring this code. Now the beauty of the prototype object is that it is shared between all objects of a particular constructor function. So in our case, anything we define on person.prototype is going to be shared between all person objects. So this means that the code that we have on line 13, the alert call, this is no longer true because Jeremy.getFullName is equal to Jeffrey.getFullName. Because what we have done here is we've created getFullName only once, and it's defined on the prototype, and that means that we are using less CPU time and less memory. I know that this is a simple example, but this illustrates why I say if you're not using the prototype, you are writing inefficient code. Before we changed this code to use the prototype, we were using more CPU time and more memory. And then after we refactored it to use the prototype, we're not. So it is a rule that really should be followed because that's just how JavaScript was designed. Well, let's look at one last example because I think it's important to look at the actual anti-pattern that started this. Here we have a constructor function. It has a local variable called thisIsPrivate, and then there is a bar method defined inside of the constructor function that references that local variable. So when we create a foo object, that local variable is kept in memory because it's being accessed by that bar method. And this is where privacy comes in. Because it's a local variable, it cannot be accessed by anything outside of the scope of that foo. The foo constructor function. That's why the bar method is defined inside of the constructor so that it can access that local variable. And this, or at least this capability, gives us the power to allow or deny access to that value. As it is right now, there's one method that returns that value, but we could modify it, or we could add another method to change that local variable if we wanted to. Now, I fully understand the want and the need for private object members in JavaScript. Frankly, it's a feature that needs to be in the language, and thankfully it will be added in a later version. But to use a closure to create private properties and methods, the side effect outweighs the benefit, especially whenever you're talking about memory, because once you consume a chunk of memory, that memory is in use and cannot be reused until you free it up. So how would I do privacy? Well, I wouldn't do it this way. I would use an older pattern which uses the underscore to begin the property or method name that is supposed to be quote-unquote private. Now, no, it's not private. It is easily accessible, but for the most part, developers are going to recognize the underscore and say the author wanted this to be private. I'm going to respect their wishes and leave it alone. Of course, there are going to be people that aren't going to respect that, but then again, they could also open up the file and, make it public if they wanted to. For those people that don't recognize the underscore, there is going to be at least the contrast between the underscored members and then, the normally named members. So they're going to recognize and say, hey, there's something different about these. I probably should leave this alone. So is it a perfect solution? No, but it is a more efficient solution and therefore a more performant solution. And with that, I'll get off my soapbox for that particular subject. To sum things up, be mindful of where you define your functions. If you define them inside of another function that will be executed multiple times, move them out of that function. If you're creating a data type, define the methods on the prototype. The general takeaway is don't define functions inside of other functions that will be executed repeatedly. So with that, I hope you enjoyed this lesson on JavaScript performance. My name is Jeremy McPeak. Thanks for watching.